Today we're going to work on some of the different reactions that can be used to synthesize amines. And we're going to start by reviewing reactions that you've already learned that will synthesize amines. We have right now 3 different reactions that you already know. And most of them are reactions that are pretty recent, so they're things that are not really far tucked away into your brain. The first one that we're going to look at is converting an alkyl halide to an amine. In this reaction, we're going to start with, obviously, an alkyl halide, and we're going to react it with the cyanide ion. This is going to be an SN2 reaction, so this aspect of the reaction is from fall quarter, a long time ago. But once you have made this nitrile, where you substituted the leaving group, the halogen, for the cyanide group, then you can do a reduction on the nitrile. And this reduction part is a relatively new reaction, something that we learned this quarter, so it's pretty fresh in your brains. With strong reducing agent LAH, we end up basically hydrogenating the carbon-nitrogen triple bond. So we end up adding 4 hydrogens to the molecule, to the carbon-nitrogen triple bond with LAH and H2O. And let's put some conditions on this reaction. Because this first step is an SN2, our alkyl halide can't be tertiary. And that's really the only condition that we have for this. There is one problem on sapling that uses an alternative set of reagents at this point in the process. So instead of using LAH followed by H2O, it uses LAH followed by H3O plus, followed by OH minus, and we will end up getting the same product. It's just really, it's kind of a silly, redundant way to go about doing this reaction. Let's kind of break down the difference between just step 2 water versus step 2 acid, step 3 base, all these extra steps in the process. The amine that you make in this reaction is a base because amines are bases. So if we do, I'm going to do, just going to draw one out. Let's say we have bromoethane and we react it with cyanide. We're going to end up with this molecule right here. And we react it then with LAH. And that's going to add, let's react it with LAH followed by H3O plus. That's going to convert to the amine by adding hydrogens to the carbon and the nitrogen of the nitrile group. And because amines are bases and we have this step 2 H3O plus, we're actually going to protonate that nitrogen of our amine product. And then in order to get it back to an amine instead of an ammonium, we're going to bring that strong base in and deprotonate. And so again, it's really a redundant set of reactions, and it's more straightforward to just do step 2 H2O. When you're doing this reaction, like always with cyanide reactions, make sure you're watching out for that carbon that you're adding in the molecule. Don't lose it. So continuing with our review, we also learned this quarter synthesizing an amine from a carboxylic acid. So this is going to be a very similar reaction. We could take any carboxylic acid that we want, react it with thionyl chloride, react the thionyl chloride with excess of ammonia, which makes an amide, and then follow that up with our reducing agent LAH, followed by H2O or H3O plus. It doesn't really matter. This time when we're doing a reduction with LAH, we're reducing the carbon-oxygen double bond. So we're still reducing, but we're reducing at a different site. Again, be careful with your carbons. You want to make sure you're not losing carbons as you move through this reaction. And even though I'm calling this, and your book is calling this, synthesizing an amine from a carboxylic acid, you really can start at any point on this path, synthesizing amine from an acid chloride, synthesizing an amine from an amide. It's kind of encompassing all of those reactions together. And then our last reaction for a review is to synthesize an amine from benzene, starting all the way back at benzene. If we wanted to synthesize an amine, the first thing that we would need to do is nitration, which is nitric acid followed by sulfuric acid. This puts the nitro group on the ring. And then that nitro group can be reduced down to an NH2 group. There's two different sets of reagents that we can do for this last step. We can do tin 2 chloride, SnCl2, in acid, and that will give you this amine, which is aniline. Or you can accomplish the same thing with zinc and HCl. Be a little careful if you're using the zinc HCl. This can react with other functional groups. So depending on what else you might have on the ring, this might be something that you would prefer to do the tin reaction. Zinc and hydrochloric acid are both very easy to work with and very cheap, so that would be the ideal choice if you were actually in the lab. So